Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. So this is part 2 video on the chapter of quadrilaterals where I will solve the problems of exercise 15 from the textbook of author RS Aggarwal. If you have not watched the part 1 video where I have discussed about the theoretical concepts of quadrilaterals, then I highly suggest that you please watch the part 1 video. This video is part of the playlist CBSE Maths for Class 8 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos for the first time and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel. And also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started in solving the problems of exercise 15 of chapter Quadrilaterals from the textbook of author RS Aggarwal. Okay, so I have the problems of exercise 15 on the left hand side, and on the right hand side I will solve the problems. I'm not sure whether the fonts of the problems are looking big enough so that you can read them, but anyway I will read the problems before solving it. Okay, so let's start solving the problems. Question 1, problem 1, these are fill in the blanks. Part 1 says a quadrilateral has, we know a quadrilateral has 4 edges, so it will be 4. Part 2, a quadrilateral has how many angles? It has 4 angles, again 4. So a quadrilateral we know has 4 vertices, 4 angles and 4 sides. So part 3 is asking a quadrilateral has how many vertices? So 4 vertices, no 3 of which are collinear. So in a quadrilateral, if you take any 3 vertices, they are non-collinear. So no 3 of which are collinear. So the second fill in the blanks will be collinear. That is, no 3 points or vertices of a quadrilateral are collinear. Okay. Part 4. A quadrilateral has how many diagonals? It has 2 diagonals. Okay. Part 5. A diagonal of a quadrilateral is a line segment that joins two dashed vertices of the quadrilateral. It will be two opposite vertices. So we know that in a quadrilateral, a diagonal is formed by joining the two opposite vertices of a quadrilateral, and we know that there are 2 pairs of opposite vertices. So there will be 2 diagonals in a quadrilateral. Okay. Part 6. The sum of the angles of a quadrilateral is 360 degree. Okay. This was question 1. Fill in the blanks. These were all straightforward fill in the blanks questions based on the very basic properties of quadrilaterals. Okay. Question number 2. These are there is a figure given and we have to answer some questions regarding their angles, adjacent sides, adjacent angles, opposite angles. Let's quickly draw the figure, the quadrilateral. This is more or less, I'm not, obviously it is not the exact figure anyway. So this is the quadrilateral given. A, B, C, D are the vertices. And okay. So part 1, it is asking how many pairs of adjacent sides are there. So we have already discussed in the part 1 video that there are 4 pairs of adjacent sides in a quadrilateral, and 1 pair of adjacent sides is obtained based on a particular vertex. So if you consider the vertex D, then the pair of adjacent sides having the common endpoint as D are DC, CD and AD. Similarly, for every vertex you will get a pair of adjacent sides. For vertex D we are having AD and DC. For vertex A, we will have AD and AB. For vertex B, we will have AB and BC. And finally, for vertex C, we will have a DC and BC. So it is asking how many pairs of adjacent sides are there. So there are four pairs, okay, and name them. So we have to name the adjacent pairs of sides. So we can say one is AD and DC, another one is AD and AB, another one will be DC, BC, and another one will be AB and BC. So these are the four pairs of adjacent sides. Okay. The second part is how many pairs of opposite sides are there. We know that opposite sides are there. There are two pairs of opposite sides in a quadrilateral. For this quadrilateral ABCD, the opposite sides are one pair of opposite sides are DC and AB, and the other pair of opposite sides are AD and BC. So what are opposites? What is a pair of opposite sides? A pair of opposite sides in a quadrilateral do not have any common endpoints. That is, the two sides are said to be opposite if they do not have any common endpoints. As you can see, the side DC and AB, the side DC has endpoints C and D, and the side AB has endpoints A and B. So they are totally different. Similarly, for the pair of sides AD and BC, the side AD has endpoints A and D, and the side BC has endpoint B and C, and they are totally different. So these are the two pairs of opposite sides in this quadrilateral. Okay. Part 3 says how many pairs of adjacent angles are there. How many pairs of adjacent angles are there? Now, an adjacent angle in a quadrilateral is obtained from a particular side. See, if you take any side, let's say the side BC, this side, if you take this side, first of all, the angles of a quadrilateral means its internal angles, and the internal angles of a quadrilateral are named after its vertices. So this angle, even though this angle is actually angle DCA, but it is usually represented as the vertex angle after the it is named as angle C. So this is angle C, this is we name angle B, and this is angle A, and this is angle D. So these are the four angles of the quadrilateral. Now what is so the question is how many pairs of adjacent angles are there. So two angles in a quadrilateral are said to be adjacent if they belong to the the vertices, if they have a common arm. So for example, the angle C, if we consider the angle C and angle B, angle C and angle B both are having the common arm BC, because the angle C is made up of the arm DC or the side DC and the arm BC or side BC. Similarly, the angle B is made of the arms of angle B are AB and BC. So we can see that angle C and B are having the common arm BC. So angle C and B are adjacent angles. Now in a simple way to understand is that every side will have two endpoints which are the vertices, and those and the angles are named after those vertices are the adjacent angles. So clearly we can say how many pairs of adjacent angles are there. Since we can have a pair of adjacent angles for a particular side, and there are four sides, so there will be four pairs of adjacent angles. Let's name the adjacent angles. We can say angle C and angle B is a pair of adjacent angles. Angle A and angle B is another pair of adjacent angles, as as vertices A and B are the endpoints of the side AB. Similarly, if we consider the side AD, its endpoints are A and D, vertices A and D. So we will have angle A and angle D as another adjacent as another pair of adjacent angle, and finally we will have angle D and angle C. Okay. Part 4. Uh, Part 4 says uh, how many pairs of opposite angles are there? There are two pairs of opposite angles in a quadrilateral where uh, one pair of opposite angles are formed from the opposite vertices. Since there are two pairs of opposite vertices in a quadrilateral, therefore there are two pairs of opposite angles. So for this quadrilateral, we can say since we know that vertices B and D are opposite vertices, therefore angle B and angle D will be a pair of opposite angles. Similarly, vertices A and C are opposite vertices, so we have angle A and angle C as a pair of another opposite angles. Okay. Part 5. The sum of the angles, how many diagonals are there? There are two diagonals. A diagonal is formed by joining by joining two opposite vertices of a quadrilateral. Since there are two pairs of opposite vertices, we have two diagonals. The first diagonals is by joining the pair of opposite vertices B and D. So BD is one diagonal, and the other diagonal is AC by joining the other pair of opposite vertices, which are A and C. Okay, so that was question number 2. Question number 3 says, prove that the sum of the angles of a quadrilateral is 360 degree. Now, since a quadrilateral, from the formula based on the polygons of n sides, we know that the sum of interior angles of a convex polygon of n sides is 180 degree multiplied by n minus 2. Now, what is a quadrilateral? A quadrilateral is a convex polygon having 4 sides. So, for a quadrilateral, we know the sum of the internal angles will be 180 degree, n will be 4, so 4 minus 2, this is 180 degree into 2, this is 360 degree. So this is based on the formula of n-sided polygon, n-sided convex polygon, or yes, that is from the formula 180 degree multiplied by n minus 2, where n is the number of sides of a convex polygon. Now geometrically, how do we prove that the sum of the internal angles of a quadrilateral is equal to 360 degree? So let's say very general quadrilateral. Let's say this is a quadrilateral ABCD. ABCD. So we need to prove that angle A and angle B. We need to prove that angle A and angle B, sum of angle AB and angle C is equal to 360 degree. So the way we prove is that we create a diagonal. Any diagonal will do. I am considering the diagonal AC. You form the diagonal AC. Now you will see that the diagonal AC has divided the whole quadrilateral into two triangles, triangle ABC and triangle ADC. Now we will use the angle sum property of a triangle. We know that the sum of the angles of a triangle is equal to 180 degree. So in triangle ABC, applying the angle sum property, we have angle B. Angle B is also the angle of triangle ABC, and also it's an angle of the quadrilateral ABCD. So in triangle ABC, we will have angle B plus angle BAC plus angle BCA is equal to 180 degree, using the angle sum property of a triangle. We know this from the properties of triangle. Okay. Now mm, in triangle, so let this result be, we name it this equation or result as 1. Now in triangle, the other triangle, that is triangle ADC, using applying the angle sum property, we have angle D plus angle angle DAC plus angle DCA is equal to 180 degree. Okay, let this result or equation be, we name it as equation 2. Now adding, if we add the two result or equation, that is, when we say, what do we get when we add two equation? We get another equation where the LHS will be the sum of the LHS of all the equations we are adding, and the RHS will be the sum of the all the individual RHS of the equations we are adding. So we are adding two equations, 1 and 2. So adding 1 and 2, we will get another equation where the LHS will be the LHS of equation 1 plus LHS of equation 2. So we get angle B, the LHS of equation 1 is angle B plus angle BAC plus angle BCA. This is the LHS of the equation 1. We will add to this the LHS of the equation 2. So we have angle D plus angle DAC plus angle DCA equal to, we add the RHS of equation 1 and 2, that is 180 degree plus 180 degree. So we get this new equation. Now if we simplify the LHS, we get angle B, angle D. Now if we consider, if we the sum of angle DAC, we group together the angle DAC and angle BAC, and we are left with the other two angles, that is angle angle DCA plus angle BCA. This is equal to, on the right hand side we get 360 degree. Now if we further simplify the LHS, we have angle B plus angle D. Now what is angle DAC plus angle BAC? So DAC is this angle, DAC is this angle, and BAC is this angle. If you add these two angle, you can see that it will be angle A. So we have angle A. Similarly, if you add angle DCA, DCA is angle, this angle, and angle BCA is this angle. If you add them, we get angle C. So we get angle C is equal to 360 degree. Hence it is proved. On the left hand side, we are having all the angles of the quadrilateral, that is angle A, angle B, and angle C, and angle D. Sum of all the angles of the quadrilateral. On the right hand side, we are getting 360 degree. So it is proved that the sum of all the angles of a quadrilateral is equal to 360 degree. Okay, let's do problem number 4. Let me see if I can zoom in a little bit. Okay, the three angles of a quadrilateral are 76 degree. The three angles given are 76 degree, 54 degree, 54 degree, and 108 degree. It is asking find the measure of the fourth angle. Okay, so we know that sum of angles of a, I am using this symbol for to mean a quadrilateral. So sum of angles of quadrilateral we know is 360 degree. Now let we assume find the measure of the fourth angle. Let measure of fourth angle be x degree. So we know that sum of the angles of a quadrilateral is equal to 360 degree. So we must have 76 degree plus 54 degree plus 108 degree plus x degree is equal to 360 degree. So this implies 76 plus 54 plus 108 plus x, this much degree is equal to 360 degree. Now we can ignore the degrees and compare the absolute values, equate the absolute values, and we have 76 plus 54 plus 108 plus x is equal to 360. So this implies if we add up all the constants in the LHS, we have 76 plus 54 is 130. So we have 238 plus x is equal to 360. So this implies x is equal to 360 minus 238, which is equal to 122 degree. I hope I am not doing any calculation mistake, but anyway, let me check the answer. It's better that we check the answers. Exercise 15. Exercise 15, this is question number 4. Question number 4, exercise, it's 122 degree. Okay. So the fourth angle is 122 degree. Okay. Let's do question number 5. The angles of a quadrilateral are in the ratio 3:5:7:9. Find the measure of each of the angles. So let the quadrilateral, let ABCD be the quadrilateral. You can name it. You can also name it XYZ, PQRS. Anything you can name, any name you can give to the quadrilateral, but please use capital letters and in sequential order. So let ABCD be the quadrilateral. Now the ratio of the angles, also let that angle A is to angle B, angle C, angle D. The ratio of angle AB, the ratio of angle A is to B, the ratio of the angles ABCD, let this be given as 3:5:7:9. We know that how do we find the quantities whose ratios are given? We consider using the parts. We assume the value of each quantity to be a multiple of each part by multiplying it by x. So let angle A be 3x degree. Angle B be based on these are, since we are assuming that the ratio 3:5:7:9 is of the angles ABCD, so we can assume that angle A will be 3x degree, angle B will be 5x degree, angle C be 7x degree, and angle D be 9x degree. Now we know that the sum of the angles of the quadrilateral is equal to 360 degree. So we know that angle A plus angle B plus angle C plus angle D is equal to 360 degree. So this implies, as per our assumption and the given ratio, we have 3x degree plus 5x degree plus 7x degree plus 9x degree is equal to 360 degree. If you simplify, add up all the degrees of the LHS, we get 3x plus 5x is 8x, 8x plus 7x is 15x, 15x plus 9x is 24x. So we have 24x degree is equal to 360 degree. If we ignore the degrees, we have 24x is equal to 360. This implies x is equal to 360 divided by 24. Okay, so this will be equal to 1 and 125. So x is 15. X is 15. So therefore, angle A is equal to 3x. So 3 into 15 this much degree. This is equal to 45 degree. Angle B is equal to 5x degree. So we have 5 into 15 degree. This is equal to 75 degree. Angle C will be equal to 7x, which means 7 into 15 this much degree. This is equal to 105 degree. And angle D is equal to 9x, that is 9 into 15 this much degree, and this is equal to 135 degree. So the angles are 45 degree, 45, 75, 105 and 135. Let me quickly check the answers. The answer is it is 45, 75, 105 and 135. Okay. So these are the angles of the quadrilateral. Okay, let's do the next problem. Question number 6 says a quadrilateral has 3 acute angles, each measuring 75 degree. Find the measure of the fourth angle. So 3 angles is given to be 75 degree. What is the fourth angle? So let's say the quadrilateral is ABCD. So we have angle A plus angle and also let the 3 angles, the 3 equal angles are angle A, angle B and angle C is equal to 75 degree. Okay, so we must have angle A plus angle B plus angle C plus angle D, that is based on the assumption that the quadrilateral is ABCD. We will have this will be equal to 360 degree, because the sum of the angles of a quadrilateral is equal to 360 degree. Now this implies angle AB and C, they are all equal and given to be 75 degree. So we have 75 degree plus 75 degree plus 75 degree plus angle D is equal to 360 degree. This implies if we simplify the left hand side, we have 3 times 75 degree. So 75 degree, so this is 3 into 75 degree plus angle D is equal to 360 degree. 3 into 75 is 225 degree plus angle D is equal to 360 degree. This implies angle D is equal to 360 degree minus 225 degree. This is equal to 5, 3 and 1, 135 degree. So the fourth angle is 145 degree. Let me check the answer. Question number 6, it is 135 degree. Okay. Let's do question number 7. Question number 7 says 3 angles of a quadrilateral are equal and the measure of the fourth angle is 120 degree. Find the measure of each of the equal angles. Okay, so let each equal angles measure x degree. So we will have since the sum of the applying the angle sum property of the quadrilateral, we must have x degree plus x degree plus x degree plus the fourth angle is given to be 120 degree, and this the sum of the angles of a quadrilateral is equal to 360 degree. So we must have x plus x plus x plus 120 degree is equal to 360 degree. Simplifying, bringing the 120 degree constant 120 degree on the right hand side and simplifying the left hand side, 3x terms, we have 3x degree is equal to 360 degree minus 120 degree, which is equal to 240 degree. Ignoring the degree, we have 3x equal to 240. So this implies x is equal to 240 by 3, which is equal to 80. So x is 80. So it is asking find the measure of each of the equal angles. Therefore, measure of equal angles is 80 degree. Since we have assumed the equal angles to be x degree and we have found x to be 80, we can say that the equal angles, the three equal angles, each measure 80 degree. Question number 7, the answer is 80 degree. Okay. Let's do question number 8. Question number 8 says two angles of a quadrilateral measure 85 degree and 75 degree respectively. The other two angles are equal. Find the measure of each of these equal angles. Okay, so two angles is given to be 85 degree and 75 degree. Okay, so let the other two angles are x degree and x degree. Since the other two angles are equal, we are assuming the measure of each of the other two equal angles is x degree. So we have these four angles of the quadrilateral, which are 85 degree, 75 degree, x degree and x degree. Now we must have the sum should be equal to 360 degree. So we must have 85 degree plus 75 degree plus x degree plus x degree is equal to 360 degree. This implies 85 plus 75, 85 degree plus 75 degree is 160 degree, and we have 2x degree is equal to 360 degree. This implies we have 2x degree is equal to 360 degree minus 160 degree, which is equal to 140, which is equal to 200 degree. Okay. Now ignoring the degree, we have 2x is equal to 200. This implies x is equal to 200 by 2, which is 100. So each equal angle, therefore each equal angles measure 100 degree. Question number 8, the answer is 100 degree. Okay, let's do the final question, that is question number 9. In the adjacent figure, a figure is given. Okay, let's first draw the figure. The figure given is we have a quadrilateral A, B, C, D. Some angles are given. Angle D is given to be 60 degree, angle C is given to be 100 degree, and it is what it has given. The bisectors of angle A and B meet in a point P. So the bisectors of angle A will be somewhat, the bisectors of angle A, let's say this B, this is the bisector of angle A, and this be the bisector of angle B, they are meeting at the point P. So this is point P. So AP bisects the angle A and BP bisects the angle B, which essentially means that these two angles are equal, and these two angles are equal. Okay. Now what is the question? Find the measure of angle APB. So we have to find this angle. So let's say this angle be x degree. Okay. So definitely we have to use the angle sum property of a quadrilateral as well as the angle sum property of a triangle. Now for quadrilateral ABCD, we know that the sum of the angles will be equal to 360 degree. So we have angle D plus angle C plus angle A plus angle B is equal to 360 degree. Okay. Now this implies angle D is given to be 60 degree, angle C is given to be 100 degree, and we have angle A plus angle B is equal to 360 degree. So this implies angle A plus angle B is equal to 360 degree minus 60 degree minus 100 degree, which is equal to 200 degree. Okay, so angle A plus angle B is equal to 200 degree. Okay, now we need to find the angle P. Now in triangle APB, using the angle sum property, we must have angle P plus angle PAB plus angle PBA will be equal to 180 degree using the angle sum property of a triangle. Okay, now we need to find angle P. It is asking to find the angle APB, which is essentially the angle P in triangle APB. Okay, now what is angle in triangle APB? What is now this implies this is angle P. What is angle PAB? Since AP is the bisector of the angle A, we can say that angle PAB will be equal to half angle A. An angle bisector bisects the angles into two equal angles. So we must have angle PAB should be equal to half of the angle A. Similarly, angle PBA will be half the angle B. We have this. Now this implies angle P plus half. If we take half common from angle half common, we get half multiplied by angle A plus B equal to 180 degree. This implies angle A plus angle A plus angle B we already know to be equal to 200 degree. So we have half multiplied by 200 degree is equal to 180 degree. So this implies angle P. Now half into 200 degree is 100 degree. Angle P plus 100 degree is equal to 180 degree. This implies angle P is equal to 180 degree minus 100 degree. This is equal to 80 degree. So angle P is equal to 80 degree. Now angle P is nothing but the angle APB, which is the question whose value the question is asking. Okay, let me check the answer. The answer is 80 degree. So these questions were pretty straightforward. Not a single question was difficult. It was purely based on the angle sum property of the quadrilateral and the triangle, and doing a little bit of algebraic manipulation, solving equation. Now As you can see that almost every chapter uh, in your course of mathematics, you will always come across word problems, and whenever you try to solve word problems, there are unknowns. There will always be one unknown, and you have to consider that unknown as a variable and solve it. So your concept of solving linear equations in one variable must be very strong. So with this, it comes to an end in solving the problems of exercise 15 of the chapter of quadrilaterals. If this video was beneficial, please like it, share it with your friends, and once again, please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. So I have come to an end in discussing the chapter of quadrilaterals from the textbook of author RS Aggarwal. Now I will keep on making 5 good problems in the other playlist, that is Maths 8 Hot. And also parallelly I will start discussing the next chapter, that is parallelograms. So please stay tuned for these videos coming very soon. I will end the video here. Thanks for watching, and until the next video, take care and bye.